I have been asked to talk a bit about the execution pattern of our program. It starts with Windows calling main. It can do this because both program and main are static. Uh, what main does is that it instantiates our engine, the one that inherits from game, and then when it instantiates, it runs the engine constructor. The constructor allocates all the fields and instantiates all our objects. Uh, and once that's done, it calls the method called run. Um, Run, on the other hand, is responsible for three things. It calls initialize, so we can set the starting values of all our variables. And it calls load graphics content, so we can load everything to the graphics card. Remember that this one is separated from initialize because it might be called several times if something happens. For example, if we lose control of the hardware to another program. And the third thing that game.run does is it calls invalidate. Invalidate is a special method that is built into all Windows programs, and what it does is that it tells Windows that something is wrong with the window of the program and it needs to be redrawn. Normally, this is done by Windows itself. Windows invalidates a window, for example, when you minimize it or when you drag and drop another window above it so that part of it is obscured. But we're gonna force it to call invalidate, or not we, XNA does this automatically for us. And then once we have done that, it gives control of the CPU back to Windows. So Windows calls all the other programs, such as the antivirus program, and then when they are finished running, it calls the onPaint method. This is the method that Windows always calls when a window has been, a program has been invalidated. The onPaint method is included in all Windows programs, and it is the one that redraws the screen of the window of the program. However, we're going to use or XNA uses the onPaint method to do something slightly different. It is going to call the method tick, and then it's going to invalidate again. Well, tick is very simple. It just calls update and it calls draw. So in essence, you have the invalidate method that kicks off a render loop, because when you invalidate, Windows calls on Paint as soon as possible, and Paint calls update and draw and invalidates again. So from onPaint we go to invalidate, and then we go back up to onPaint, and everything in between, i.e. the tick method, gets called over and over again. Now, this is not something you generally have to worry about. That's what's so great about XNA. You only have to worry about the methods that we have defined in the engine: the constructor, initialize, load graphics content, update, and draw. Let's look a bit more at those 5 in context. When a program instantiates our engine class into an object. It calls the constructor, and it allocates all the fields. The fields are the memory slots that we will store all our data in, and the constructor basically fills those memory slots with objects. At least it fills the memory slots that need objects. There are some that need data as well, and those are instead initialized by the initialize method. The initialize method uh, we have designed so that it basically just calls the initialize method of each and every object that we have created up in the constructor. And then inside each one of these, we actually assign to all the variables. Makes for cleaner code, easier to follow along. And then we do the same thing with the update method. We call update on each and every one of our objects. And we do the same thing with draw. We call draw on all of them. Okay. The one that is a bit odd is load graphics content, because this one we cannot just call load graphics content on each one of them without any parameters. We need to pass in references to the sprite batch and the texture that we are going to use. The reason why we have the sprite batch and the textures created out here instead of inside the box object or the computer object is because they might use the same one. For example, all three of these sprite batches are the same, and the box and the computer, they have the same texture. And then we change from computer sheet to cursor, and we have a new texture here for the cursor. And by doing like this, we only store one reference, even though we have two objects using it, which means that we save on a lot of memory. But basically, the structure of the engine of our 5 main methods is that each one of them calls the method with the same name on each of the objects that was created in the constructor. Can make it an example. Let's go into one of them, like image, for example. Control WS. There we have it. I'll do the image and close this. Let me just pack it up a bit. Okay. You remember how to pack it up? Control MP to expand, Control MO to shrink it all up, collapse everything. When we call the constructor of the engine class, it creates an object, it instantiates an object. So the same thing happens over here. First we allocate all the fields, and then we call the constructor of this method. This one doesn't have a constructor method, it would have been listed here otherwise. Because it only has a default one, it doesn't need to instantiate any new objects by itself. But as you can see, the load graphics content takes two parameters and just stores the references locally, so we have access to them later on. And initialize gets called without parameters because the image class should know what it's doing by itself, and it initializes all the variables. An image doesn't really have an update method. We might change that in the future, but right now it doesn't do anything. So we jump down to draw instead, and it basically uses that reference to the sprite batch that we passed in to call the draw method, pass in all the variables that we have listed, and then the sprite batch will take care of drawing everything for us. And that's about it. All our methods, all our classes look about like this. We have, of course, slightly different structures on them. The image here, image class here is a base class, and then animation inherits from this one because it adds functionality to it. You can compare that to the I'll do Control WS again. You can compare that image and animation class that animation inherits to the mouse, for example. The mouse class takes two different, I'll open that up, takes two different parts of programming and puts them together. It takes the mouse state of XNA and puts it together with an image cursor. So it works. The mouse class works like a link between these two. You can see that down here because we use the mouse state to set the position of the image. So we are basically in this class only linking these two together. We'll do that again several times as well, just like we will do inheritance with the image and animation classes. We will do that several times more over too. I hope that helps. Hope it's easier to follow along now. Gonna move on to farcier physics instead.